Huh?
Yeah.
Hi, my name is Gift Lowen. We have designed here a temperature control circuit by use of a thermocouple and the USB 6008 DAQ data acquisition card. And basically, the schematics here looks like this. We have got our PT 100 thermocouple. We have just connected to 2.5 volts, and we have got a 10 kilo ohm resistor that's in series. And also we have got the input from the temperature thermocouple, which is connected to IO number 0 for all of this DAQ card. So we also have the analog output, which is connected to the fan motor. Can be connected via a relay, the relay to activate the fan motor, but because of the lower currents we're dealing with here, we will just connect the motor terminals straight to the USB 6008 card. So that's basically the schematic for it. And here we have got the circuit. This is the LabVIEW software. With on the block diagram, we have got the DAQ assist. This DAQ assist receives the input data from the thermocouple. Converts this data, it receives the analog input as voltage, and then it works out to convert this to temperature. We have got the voltage indicator there, which is also shown here in the front panel, which is pretty much our HMI, and we have got the temperature indicator there, which is this one here. Shows also the value of the temperature that we will be receiving. This temperature can actually be replaced with a graph. You can, in place of this one, we can install a graph by just going through replace and go through the you can use the graph if you want. But we just went to this one and picked up the thermometer. So that's another way to represent this one, can be in a graph. And this is the voltage indicator. So this is the actual voltage that is going to the that is the output voltage that is being worked on by the DAQ assist number 2, which is here, and that's the voltage that runs the fan motor here. When the temperature gets up to 80, we have just said 80. We can change this value to 90. It's still okay. When the temperature gets to 90, the fan indicator light will turn on, and the fan will start running. And yep, that's basically. I'll leave it up to Deepak. You wanna say a part?
Yep. Okay. Hi, my name is Deepak. So I'm just going to demonstrate how it is going to work. As Gift mentioned, so the setup temperature is 90 degrees Celsius at this stage. So what happens, we have like a hot water and a cold water here. So what happens, because this has been programmed using LabVIEW, as he mentioned. So at the moment, it's the temperature, water temperature is 37 degrees Celsius. That shows the indicator. As soon as it reaches the 80 degrees Celsius, so the fan is going to be turned on. So what I'm going to do, I'm just going to place this temperature sensor or thermistor in the hot water, so just allowing it to increase the temperature. So what happened when this thermocouple reaches the 80 degrees Celsius, okay, it's going to turn on the motor.
Do you run? Just that it is running?
Yeah, it's running.
Yeah.
We should get the motor coming on. I think you've got a loose connection somewhere. Yeah, the motor is running.
Yeah.
You can tip back there to stop the motor.
Yeah. So I'm trying to cool the thermocouple. So yeah, it's reaching. Just
So the motor stops.
yeah,
Just
just gone down less than 90 degrees
Put it
Celsius.
back again.
Yeah. So now I'm trying to increase the temperature.
Oh, there you go.
Yeah.
Put it back there again. Stop the temperature before it goes too far.
Yeah.
Yeah. Just wait. Just hold the temperature for this to slow down. Yeah. Dip it. Yep.
It's turning on.
It's turning on. Yep. That's it.
Yeah.
Hi, my name is Isaac. We've worked on this simple thermocouple that can be used. Our system can be applied in a lot of applications. Say, for example, in an engine, combustion engines, where we need a lot of water to cool down the system because of the heating. So basically, if we can use this sensor to make sure that if the water running through the engine is hot enough, as it circulates through the system, the coolant into the radiator, where it's supposed to, using the thermodynamics principles, it's supposed to lose the heat. So if we connect this, if you have this sensor and the fan, which in this case is our actuator, once the water level reaches above the, say, margin, if we set it at 80, once the water level is so hot, then it turns this fan on. This fan will help cool the radiator and make sure that the water which goes back into the engine is a bit cooler, and then it can continue the cycle as long as the temperature is above. So basically, this simple illustration here tells us that if the water temperature in the radiator, say, is over 80, then this fan here will be automatically triggered and it turns on, and then it will start putting air onto the fan, onto the radiator, so that it helps with the cooling process and keeps the engine running. Basically, this is our simple design of the sensor as part of the project. Thank you for watching.